Hi everyone, in today's presentation we will be covering chapter 3.3, subtracting integers from the OpenStax Pre-Algebra textbook. Now in this particular presentation we will cover the following learning objectives: model subtraction of integers, and I'm going to do this on the number line; simplify expressions with integers; evaluate variable expressions with integers; translate word phrases to algebraic expressions; and finally, subtract integers in application. So basically, some word problems. So let's go ahead and get started first off with the two rules that I introduced in the previous video, chapter 3.2, covering adding of integers. So these two rules are the following. Rule number one, adding a negative is the same as subtracting a positive. Okay, so what does this rule actually mean? Well, let's apply this to the concept of money here. And let's first start off with one that is more common when we're thinking about it in terms of money, subtracting a positive. So let's say you go to a restaurant and you have $500 in your bank account. And then you go to the restaurant and you're going to spend $25 to buy a meal. So you spend positive 25 of those dollars, and you end up with $475 in your bank account after that. So adding a negative then is the same as subtracting a positive, meaning there's an equivalent way of writing 500 minus 25. And that equivalent way is if you were to charge a credit card, basically. So if you added debt to yourself. So $500 plus a negative 25, I'm adding a negative, also gets me to 475. Okay, let's look at rule number two. Subtracting a negative is the same as adding a positive. Let's again start with the more common thing, adding a positive. So let's say, again, you have $500 in your bank account, but in this case, you go to work for the day and you earn $100. So I add a positive 100. Well, at the end of the day, I then have $600, right? The equivalent way of writing this, though, is by subtracting a negative. So let's say you again have $500, but now you had your Uncle John who lent you $100 one day and you were going to pay him back. So there's a loan or an IOU out there. But then Uncle John decides, hey, you know what? It's your birthday coming up. I'm going to go ahead, Chris, and I'm going to eliminate that debt. You no longer owe me that $100. That's your kind of a birthday present for you. So that's subtracting away then the $100 worth of debt. So subtracting a negative is the same as adding a positive. In other words, you could theoretically, if you're subtracting a negative, rewrite this as 500 plus 100. And in both cases, you end up at positive 600. So rule number one type problems will decrease your value, meaning you're going to the left on the number line, while rule number two type questions will always increase your value from the initial starting number. You're going to the right on the number line. Okay, so let's apply these rules to a few questions. Let's now model the following subtraction facts on a number line. So starting with question number one, we have 4 minus 2. So positive 4, and then we're subtracting a positive 2. So if I start on the number line here, I have 4, and then I'm subtracting 2 from that. If I think about it in terms of money, I'm spending $2, right? And I go back to the left 2, and I end up at a positive 2. So 4 minus 2 is equal to 2. This is a rule number one type question. You are decreasing your overall value. Question 2 then is negative 4 minus a negative 2. So in this case, we're starting at a negative already. So a negative 4. We are then subtracting a negative. Well, remember, subtracting a negative is the same as adding a positive. So you're increasing your value. In fact, if you wanted to rewrite this question, this could be rewritten as -4 plus 2, right? Subtracting a negative is the same as adding a positive. This means I'm going back to the right 2 units. So start at -4 and I go back 1 and 2, and I end up at a -2 here. Okay, so question number 2, our result is a -2. Question 3, I now have -4 minus a +2. Now you might say, Chris, I don't see a positive next to the 2. Well, since there's no negative sign there in front of the 2, it's a default positive, right? So we would say -4 minus a +2 here. Now, if you wanted to, you could put a little plus there just as a reminder. But here we're starting at -4. Subtracting a positive decreases your value, so you're going back to the left 2 units. 1, 2, and we end up at a -6 here. And that's our result. Looking at question number 4 now, we have 4 minus a -2. So I start at +4. I then am subtracting a negative. Subtracting a negative is the same as adding a positive. You are increasing your overall value. You could rewrite this as 4 plus 2 if you wanted to. Well, 4 minus a -2 or 4 plus 2 increases your value by 2 units. And you end up at a +6 here. Okay, so +6 is your result for this problem. We're now going to look at simplifying expressions with integers and a few different parts in question series with this. So we'll look at 3 different slides with different questions, increasing levels of complexity here. So starting with question 1, we have 20 minus a -8. So we are subtracting a negative. If this was money, we would be subtracting away debt. Well, subtracting a negative or subtracting away debt is the same as adding a positive. So in this case, we are increasing by 8. If I went to my number line and kind of modeled it there, we'd be at 20. We are then increasing it by 8 units or $8 if I'm talking about money. And where we end up then is at a +28 here. Okay, so +28 is my result for question number 1. Next, we have question 2, -40 minus a +10. So we're starting at -40. If I went to my number line, this would be on the left side of the number line. And then we are subtracting a +10. In money, we would be spending $10. So I'm going back to the left then, 10 units, and I'm getting further away from 0 now. So I'm going to end up at a -50 after subtracting a +10. Okay, so that's question 2. Question 3 then is -50 minus a -25. So I'm starting again on the negative side of the number line, but I'm now subtracting a -25. In terms of money, this would be subtracting away $25 of debt. Subtracting a negative is the same as adding a positive. So this is me increasing by 25 units, which means I'm going to the right on the number line. I'm going back towards 0. So -50 plus 25, and I end up at a -25 here. Okay, so this is -25 as my result. All right, let's look at the next question series. So here I have a series of 3 integers to start. So we have question number 1, 10 minus -8 plus 2. Now the strategy I'm going to use is doing this in chunks. So starting with the first 2 integers and then going to the third. So what I'm reading here is I have a +10 minus a -8. I'm subtracting away a negative. In terms of money, this would be subtracting away debt. Well, subtracting a negative is the same as adding a positive. So I could rewrite this as 10 plus 8 plus 2. So 10 plus 8 then is 18 plus 2. And 18 plus 2 is equal to 20. Okay, so 20 is my result for question number 1. Question number 2 then is 60 plus negative 4 minus 3. So here I'm taking 60 and I'm adding a negative 4. Adding a negative, this is like you charging your credit card or putting negative $4 of debt onto your credit card. So this is the same as you spending money essentially. So you're subtracting $4 away from your debt. In fact, if you wanted to just use a single sign, you could write this as 60 minus 4 here, minus 3 if you wanted to, right? So 60 minus 4 is then 56 minus 3, and 56 minus 3 is 53. And we're done. Looking at question 3, we now have some grouping symbols here. So we have 2 parentheses, which means we're going to group these, or solve, I should say, the 2 groupings before we subtract them. So we're going to do 1 minus 6. 1 minus 6, start at positive 1, go back 6 units, you end up at negative 5. Minus symbol. 3 minus 4, then you start at 3 units and you go back 4. Or if you think about money, you have $3, you spend 4 of them, probably on a credit card or whatnot, and you end up at a negative 1. So I'm going to put the negative, by the way, in a parentheses. The only reason I'm putting this in a parentheses is to clarify that I have another subtraction symbol next to that. So here now I have negative 5 minus a negative 1. I'm subtracting away a negative. Subtracting away a negative is the same as adding a positive, so it'd be like negative 5 plus 1. Well, if I go to the number line here, and I start at negative 5, adding 1 increases my value. So where I end up then is at a positive 4 here. Or excuse me, negative 4. Okay, so negative 5 plus 1 is equal to a negative 4. All right, so that is the part number 2 for this particular question series. Let's look at part 3. Okay, so looking at question number 1 here, we have 30 minus 5, big bracket, 8 minus parentheses 4 minus 11, parentheses and bracket. So we have a larger order of operation problem. So I'm going to use order of operations now. The order of operations I prefer to use, although it is a little different in the textbook. In the textbook it says PEMDAS, which is actually more commonly used, or at least was at one point when I was going through school. Now math instructors, math educators usually use this order of operations called GEMMA, which G really is part of the parentheses, but the reason we use G is for grouping. So grouping could be our parentheses, it could also be the brackets, could even be absolute value symbols, etc., etc. Exponent then is like x squared. Multiplication and division. Actually, let me do that, actual symbols. And then addition, subtraction in this last one, okay? So starting with our big bracket, we have 8 minus parentheses 4 minus 11. So I need to do what's in the parentheses to start. So 4 minus 11 being negative 7. So then rewriting everything below this, we have 30 minus 5, bracket 8 minus a negative 7 here in bracket. So now at this point, I am going to do what's inside the bracket to finish it, which is 8 minus a negative 7. I'm subtracting away a negative 7, which is the same as adding a positive. Subtracting a negative, adding a positive. So adding 7 is my result. Adding 7 to 8 is 15. So rewriting this, I have 30 minus 5, bracket, positive 15. Now, when I have a number next to a bracket, it's like that of a number next to a parentheses in that you actually multiply. So doing 5 times 15, we have 15, 30, 45, 60, 70, 75, excuse me. Okay, so 5 times 15 is 75. So I'm going to rewrite as 30 minus 75. Now from here, 30 minus 75, if I think about it on the number line, you have $30. If you think about money and money on the number line, you have $30 and you spend $75 of that. So where you end up is then at a negative 45 here. So negative 45 is my result. Okay, so looking at question number 2 now, we have 8 times 4 minus 5 times 4 minus 6 times 3. So in this case, we have basically 3 multiplication problems that we need to solve first before subtracting them. That's the 8 times 4 part, the 5 times 4 part, and the 6 times 3 part. So 8 times 4 then is equal to 32 minus symbol. 5 times 4 is equal to 20 minus symbol. 6 times 3 is equal to 18. Okay, so from here then we're subtracting. So 32 minus 20 is 12 minus 18. And 12 minus 18, if I go to my number line and map this or model it, we're at 12. And then I'm subtracting 18. Now again, it takes me 12 basically units to go from 12 to 0, right? And then I have another 6 units to go after that. So where I end up then is at a negative 6 here. Okay, so negative 6 is my result. Looking at question 3 then, we have 5 squared minus 8 squared. So remember with exponent, this is repeated multiplication. If I was to expand this exponent out, this would be 5 times 5 minus 8 times 8. So 5 times 5 is 25 minus 8 times 8, which is 64. Now 25 minus 64, if I model this on my number line, again, I'm at a positive 25 here. And I'm going back 64 units. Well, it takes me 25 units to go to 0. And then I have 39 more units to go. So I'm going to end up at a negative 39 here as my result. Okay, so that is simplifying expressions with integers. Next, let's look at evaluating variable expressions with integers. So starting with question number 1, we have the expression y minus 5. And we're asked to solve for this when y is equal to negative 2. In other words, we're going to substitute our now known number into the variable here. So doing that, our first step is substitution. Negative 2 goes into the y variable. So negative 2 minus 5 here. So negative 2 minus 5, if I think about that on the number line here, I start at negative 2. I then am subtracting a positive 5. Well, subtracting a positive 5 decreases your value. It's like you spending $5. And going back 5 units, I end up at a negative 7 here. So negative 2 minus 5, and I arrive at negative 7. Question number 2. Evaluate the expression 15 minus z when z equals negative 12. So again, my first step here is I'm going to substitute negative 12 into this expression. But I'm going to put everything else directly the same. So I have 15. Oops, that's yellow. Weird. So let's go to black ink. We have 15 minus z. Well, the z variable is now negative 12. So I'm going to put this in a parentheses to let me know that I have a negative symbol next to it. So now I have subtracting a negative. So 15 minus negative 12, subtracting a negative is the same as adding a positive. So I could have 15 plus 12 here if I wanted to rewrite this in a little bit easier terms. So 15 plus 12 then is equal to a positive 27. Let's look at question 3. So question 3, evaluate the expression negative 4 minus x when x is equal to negative 10. So I'm going to substitute negative 10 into the x. So I put negative 4 and that minus symbol as well. And then I'm replacing the x variable with a negative 10. So at this point, I have negative 4. I start at negative 4, start in the negatives. I'm subtracting a negative 10, which is the same as adding a positive 10. So I could rewrite like this if I wanted to. On the number line then, if I was to model this, I start at positive 4, and then I'm going back to the right, right? Subtracting a negative or adding a positive increases your value, your initial starting position, by 10. So for me to go from negative 4 to 0, that's 4 units. And then I have another 6 units left. So I end up at a positive 6 here as my result. Okay, so positive 6 is my answer. Our next learning objective is to translate word phrases to algebraic expressions. So starting with question number 1, we have the difference of 4 and negative 12. The difference is subtraction. So how we would write this is we start with the positive 4, subtraction symbol, that's the difference, and then we have negative 12. Okay, so 4 minus negative 12 now. Subtracting a negative is the same as adding a positive. So this would become 4 plus 12. 4 plus 12 then is equal to positive 16. So question 1 is positive 16. Question 2, translate and simplify negative 25 minus 15. This again is a subtraction symbol. We start with negative 25, and then we subtract a positive 15 from that. So this is decreasing by 15 units. On the number line, it would be negative 25, and then you're going back to the left 15 units. And you end up at a negative 40 here. Okay, so negative 40 is your result for question 2. Question 3 is a bit tricky because of this phrasing less than. In this context, we're still talking about subtraction. We're not talking about an inequality symbol. But what a less than phrasing does is it switches the order of the numbers. So what I mean by that is I'm going to show you 2 different ways that this can be, subtraction can be written, and so show you how that differs or changes the overall expression. So you could have 20 less than 8, or you could have 20 minus 8 as an example. Now, both of these are subtraction. However, they are different types of subtraction problems here. 20 less than 8 means you are taking 20 from 8. So you would write this as 8, subtraction symbol, 20. I've switched the order of 20 and 8. 20 minus 8, on the other hand, would be written in order. 20 minus 8 like this. So 8 minus 20 then is equal to negative 12. 20 minus 8, I switch the order, would be equal to a positive 12. So be very careful with the less than. It does change the effect or the final value of your answer here. Let's now look at some questions that are applied subtraction of integer problems, or word problems, in other words. So the first question here we have, the temperature was 8 degrees Fahrenheit in the morning. By evening, the temperature dropped 15 degrees Fahrenheit. What was the temperature in the evening? So since this is temperature and kind of a thermometer type problem, thermometers often are driven with drawn with a vertical number line. So I'll have a vertical number line here. So 0 degrees Fahrenheit here. Now, if we start at 8 degrees Fahrenheit, that's about right here. So you're in the positives. Oops. You're in the positives. But the key word here then is the word dropped. This means to decrease. So you actually decrease from 8 and you go downwards by a negative 15 or 15 units here. So if I was to write this actual expression, this would be 8 minus a 15 here. And 8 minus 15 then is equal to a negative 7. So you would be at negative 7 degrees Fahrenheit in the evening. Question number 2. Maria had $45 in her checking account. She used her debit card to buy groceries for $60. What is her new checking account balance? So in this case, Maria is in the positives currently. She has $45 in her bank account. She then uses her debit card to buy groceries for $60, meaning she spent $60. So she is spending more money than she actually has. So we know we're going to be in the negatives then. Modeling this on the number line, I start at a positive $45, and then we're going back a total of $60. Well, to go from 45 to 0, this is $45 in total that she spent. She then spent 60 in total, which the difference between 60 and 45, basically meaning subtracting the two, you get $15. So in other words, where Maria would end up in her checking account is at negative $15 here. Okay, so negative 15 is Maria's result. All right, so that is the final question in this presentation. So to recap the learning objectives for this presentation, we looked at modeling subtraction of integers on the number line. So in other words, we applied the two rules. Rule 1 will decrease our value. Rule 2 increases our value, right on the number line or left on the number line. Second, we looked at simplifying expressions with integers. Third, we looked at evaluating variable expressions with integers by inputting or substituting a number for a variable. Then we looked at translating word phrases like find the difference of two numbers in algebraic expressions. And then finally, we looked at some algebraic, or some, I should say, application type problems, word problems for that. Okay, so go ahead and get into the chapter reading to do some extra problems. If you have any questions, feel free to reach out. Thank you, everyone.